Hello, everyone. Welcome to our presentation. Our project is investigating extension permission model. So Chrome provides developers with extension APIs that can extend the capabilities of the browser. By downloading these Chrome extensions, users can customize their browsing experience. The Chrome extension store is full of extensions developed both by Google and independent companies or developers. Chrome permissions basically define the capabilities of the extension by limiting which APIs it can use. Our project is to investigate how permissions are used in the wild and how secure are these current practices. So these are the steps that consisted of our methodology. We initially collected a representative set of more than 1,000 extensions from the Chrome extension store. We say that this is representative because we try to keep a similar amount of extensions from each of the 12 categories. We then analyze the permissions data from each of these categories to observe which ones are the most frequently requested permissions. We observed trends among different categories, which extensions were more dominant in which category, and then we compared them. We also detected an anomaly in the case of the photos and sports category, which we will later come to in this presentation. Then we picked out a few of the most used permissions, and then explored what exploits can be created out of them, and we will demonstrate a few for you later. So these were the top 20 most requested permissions out of all of the set that we had created. Storage is a top requested one, and tabs is a close second. Then we break down into each individual category, and we can again see that storage is almost always the most used category, and tabs is a close second. For the case of photos and sports, there's a special permission which we see in the top 5 categories. It's a specific URL, which is a free add-on, and the sportifytab.com. It is strange because these set of extensions were huge in number, and for a specific URL to be requested by a majority of them is a strange thing.
So next we will be talking about the free add-on and Spotify host permissions. We tried visiting freeaddon.com, but we stopped from visiting it by Malwarebytes browser guard extension, as it suspected the website to be running a potentially unwanted program. We can see this in the video in this slide. Anyways, moving on, the two sites mention each other as partners, and hence we'll be addressing them as such. They also claim to be developers to the extensions that request their host permission. They also claim that the PUP flag is a false positive, and that it's a false positive by Malwarebytes, and that they are trying to communicate with Malwarebytes to resolve this. Next slide. The top site permission allows the developer to use the Chrome.topsites API. The developer can look at the recently most visited websites using this API, and this information can be sold to advertisers for money. At the bottom of this slide, you will find the output of using the get method while using this API. This can also be used for social engineering attacks. For example, attackers might trick the user into trying their related but maybe malicious websites instead. Next comes the management permissions, which allows the developer to manage the list of extensions or applications that are already installed on the user's browser. The developer knows what apps or the extensions a user has installed on the browser and can sell this information to advertisers. The developer can also prompt the user to disable or uninstall other extensions that might be competitors. We actually managed to create an extension that did the same thing, but in the interest of time, we will not be demonstrating it. However, you can see the uninstall prompt being shown to the user after our extension managed to invoke the uninstall method. Next.
The Chrome Tabs API is used to interact with the browser's tab system to create, modify, and rearrange tabs of the browser. What's shocking is that most Chrome Tabs methods and events can be used without declaring any permissions in the extension's manifest file. It is said that the browser is how the user interacts with the internet, but the tabs are how the user interacts with the browser. With the all-encompassing scope and broad overarching powers of the Tabs API, we felt that it merited the closest examination and developed 3 exploits to showcase its potential danger. First, the YouTube views generator.
This is the demonstration of another attack. Here we see a case where an attacker would gain financial benefit from, let's say, views on a YouTube video or an ad site. Usually when you open a YouTube video in a new tab, it doesn't play unless you visit it, but this script opens a new tab and it plays the video as well. It also mutes the video so the user cannot detect it. This attack is specifically targeted at users who may leave their browsers open unattended for long periods of time, or those who may have several tabs opened for most of the time. So we can see that this video had been playing for a while, and that if in a mix of different windows or tabs, the user may not notice it.
Next, we'll showcase the general malicious extension. The first bit of functionality added was to create a fake user sign-in page, which would be presented to the user the first time they navigate to google.com. This is an example of a real form for comparison. The fake sign-in form does hyperlink out to various official links and provides error checking to give the illusion that the user is putting in their data into a real sign-in form. Here we can see that the server was logging the user's activities. We can see the inputted Google username and password, various operating system information like the app version, language used, host OS, and vendor name, as well as location data. It also takes a screenshot of the tabs every 5 seconds. If we go and search for Wikipedia, we can see that the Google search was logged. And when going to the web page, we can see the server picked that up as well. The extension also acts as a keylogger, and when I type in Carnegie Mellon University, the server picks up those keystrokes. And when going to the page, that's logged as well. The extension also grabs anything in the user's clipboard. So if I do a Control-A, Control-C, everything copied will show up on the server. Even with the extension installed, the user can still go to their favorite sites like BBC, Facebook, Pinterest, and Instagram, and see no noticeable functionality loss. When navigating to Gmail, the extension will also automatically pull all detectable inner text that is contained within the Gmail email snippets. Lastly, I wanted to give the server more control over what was being logged in when. To do this, a command and control server was created. By deselecting all the flags and entering text into the text box, we can see that nothing is being logged. So here the keylogger functionality doesn't work. However, by enabling the settings, the functionality returns. Lastly, we're going to show the Facebook password reset attack. Our Facebook OTP proof of concept attack leveraged much of the functionality seen previously. The attack assumes that the user already has signed into their Gmail account, and that email was used to create their Facebook account. The first step is to tell Facebook that the victim has forgotten their password and have them send an OTP to the user's inbox. If the victim had already had Gmail open, then the extension's get email data function would have already retrieved it. But if the page is not being used, the attacker can force all saved Gmail accounts to open via the command and control server. The extension quickly opens the tabs, gets the requisite data, and then closes the tabs all under 2 seconds. The OTP can then be seen in the server output and can be used to change the victim's password. Once the new password has been entered, the attacker has total control over the victim's Facebook account. To obfuscate the attack, the email is removed by deleting their entry in the page's DOM tree. The email that Facebook sends as confirmation that the account password has been changed is deleted in this manner as well. By turning off the extension, the emails can now be seen.
Here is the timeline for how we have completed our work so far. In green is the work we have done since milestone 2, and in yellow is the work that is still ongoing. Moving on, we have identified some problems with the current permissions model. Through our testing, we've seen that the permission categories are too broad. For example, an extension that wants to read something off from a web page can technically read and modify the DOM of other web pages using the tabs permission, as we showed from our demonstration. Also, users don't understand permissions and what they're capable of, and are usually conditioned to just accepting them, especially if only asked for at install time. Furthermore, developers do not minimize permission usage and ask for more permissions than they actually need. Moving on, we also propose some recommendations to fix these problems. We propose that the permissions are made more fine-grained. We can also change the permission model so that the user is prompted to allow the extension to certain permissions only when required. This way, the user will be able to make more informed decisions about permissions, and this will also prevent background use of the permissions without the user's knowledge. We can also look to implement user-driven access control. We also propose that the extension review process before an extension is listed on the web store should be made more rigorous. Finally, we ask that Google Chrome mandates that developers only use permissions that they need to for the functionality of their extensions. Finally, to conclude, we downloaded around 1,050 app extensions from different categories and analyzed the permissions that they used. We looked at some of the most used permissions and how they could be used in malicious contexts. We engineered demonstrations where we managed to use these permissions in various degrees of maliciousness. We identified problems in the current permission model in Chrome and browsers in general, and proposed some recommendations to fix or mitigate these problems. That concludes our presentation. We'll be happy to take any questions that you might have. Thank you.